All right. Thank you all for coming. Today I'm going to talk about Cosmos DB, especially in the context of Entity Framework. So who here is currently using Cosmos DB? Show of hands. Right, about 5 to 10 people. So who here is using Entity Framework? All right, like 90% of the room. Who here loves Entity Framework? That's a tricky question. I know. All right, my name is Thiago Passos. I'm a solution architect. I used to work for SSW, these guys here. That's why the room is a bit packed because of these guys. I've been in the industry for about 20 years. If you want to follow me on Twitter or my blog, I constantly posting things about .NET or Azure or front-end development. So that's what I've been doing the last 5 years or so, and that's it. I'm based in Brisbane. Well, I was based in Brisbane until I sold everything, and that's my current office. So I'm traveling with my family around Australia, so if you want to check it out as well. Back to the real agenda. Today I'm going to talk about what is Cosmos DB. I'm also going to share a bit of the cost involved in Cosmos DB. I'm going to show you how to get started, and I'm going to share some of the toolings I use to work with Cosmos DB. And at the end, I'm going to add EF Core to the mix. So to start, what is Cosmos DB? Cosmos DB is a multi-model database service for managing data at planet scale. It's also classified as NoSQL, right? From this sentence here, the NoSQL and the scaling is pretty easy to understand, right? But what about the multi-model? When I first started using Cosmos DB, the multi-model got my head. And the multi-model means you have a bunch of APIs that you can use to talk to Cosmos DB. And that happens when you create your instance, right? So there are currently 5 APIs available to talk to Cosmos DB. I've got a lot of background on SQL, so for me, the easiest one would be the core API, right? Because I'm familiar with SQL. And the cool thing about having all these different APIs is I don't need to learn something new to talk to a document database. I can use the knowledge that I already have, which is SQL, to talk to Cosmos DB. But the cool kids coming from the uni right now, they know MongoDB, they know Cassandra, so they can use that as well, right? But think about Cosmos DB as a big umbrella. So no matter which API you choose, they're going to fit into one of those database types, but all of them will have these cool features. So they all going to have the global distribution. They're all going to have the ability to scale out almost unlimited. They'll have the guaranteed low latency. They'll have all this comprehensive SLA, which I'm going to touch soon. And they have these 5 consistency levels, which I'm going to go through as well. But let's start with the global distribution. So remember back in the day when we had our SQL database sitting in a box in the corner of the office? If you wanted that database to be replicated in a different building or a different city, that was really painful, wasn't it? To keep in sync, it was really hard. And very often you would lose data and so on. Well, nowadays it's way easier. You can replicate SQL and it's much easier than it was before. But with Cosmos DB, it's a whole new level. So let's have a look at that. So I created my Cosmos DB instance in Australia East, as you can see, the right region. And now my business is growing, and I want to create some read regions in Asia, in the UK, in the US, and Brazil. And that's how simple it is to replicate your read instances across the globe, right? So as soon as you add that, your database is going to be as close as possible to your customers. So what about the consistency levels? What's that about? So Cosmos DB has 5 consistency levels, starting from the strong. And the strong, obviously, is the most expensive one. And what that means is when you write something in your write region, all the read regions will have the data immediately with no delay, or with virtually no delay. So that's the strongest one. After that, we have the bounded stateless, where you have the write region and the read region together, and together they have like a strong consistency. But all the other read regions will have a slight delay of 5 seconds or 10 versions, whichever is smaller. That's still quite acceptable, isn't it? The default one is the session consistency. And what that means is all the regions in the same session will have this strong consistency, and all the other read regions will have a slight delay, which is still quite acceptable. The delay is not huge. Then going down a little bit, we have the consistent prefix. And then things start to slow down a little bit as per the graph. But it's still not a big deal. But the key point in here is that the data coming in the write region is coming in the same order in the read region. So if that's what you're expecting, to have the data in the same order, the minimum level of consistency is this one. The last one and the cheapest one is the eventual. So the first time I saw this graph here, I thought, why would anyone use that? Because as the data comes through, you can read the data in all sort of orders. So it doesn't make even sense at all. But if you think about the eventual consistency, so has anyone used eventual consistency here before? All right, just a few hands. Outside Cosmos DB right now, I've got a story about the eventual consistency, which is pretty good. Amazon, the store, they made a decision, a business decision, to start using eventual consistency. And on Black Friday, they had like hundreds of thousands of users coming to the website and making purchases. And every time someone purchased anything in the website, they would check the stock, they would see if the item was in stock, and after the purchase, they would go and reduce from the stock. Pretty standard, right? But once you have hundreds of thousands of users, that's going to slow down. And every write and every read you do is going to slow down the system. And because of that, they were losing a lot of sales, right? Because the site was slowing down and they were losing sales. So instead of doing that, they decided to use the eventual consistency model, where they wouldn't read, they wouldn't write the stock, they would just sell. And eventually, every couple of hours, they would go and consolidate the stock, right? And by doing that, they wouldn't lose a sale because of the speed. But sometimes they would come back to the customer and say, hey, I'm sorry, we don't have this item in stock anymore. Do you want the credit back, or you want another product? So for them, it was really profitable just to come to a few customers and saying sorry, then lose sales because of the speed. But I'm not talking about Cosmos DB in this instance, but just so you can understand how this works. So with the eventual consistency, as you write, eventually all the read regions will come into sync. And that's pretty powerful if you're talking about something that's going to show stats of like number of tweets or number of likes or number of followers. It doesn't matter if right now you have one follower behind here than you have in the US, because eventually everything is going to come into sync and it's going to be fine. So if that's your model, then that works well. What about the comprehensive SLA? So Microsoft promises that they're going to deliver 99.99% of availability, throughput, consistency, and latency. And they commit to that. And they have in their documentation, if they don't deliver that, they're going to give you 10% back in credits. And if they don't deliver 99%, they're going to give you 25% back, which is pretty awesome, right? So why would you use Cosmos DB in the first place? Well, it was awarded the Technology of the Year in 2018, and it's just growing. Cosmos DB is awesome. You should definitely try it out. But you should choose Cosmos DB because of the high performance, the availability, It's completely managed, so you don't need an IT guy or a DBA to set it up for you, right? It's almost unlimited scaling, so you pay the price, absolutely, if you scale that much. But this is awesome. And the key point for me as a developer, and I'm sure most of you here are developers, so who here is a developer? All right, so 99% of the room. So for a developer, having the ability to choose the API you're going to use to talk to your database is awesome, because then the learning curve is going to be minimum, right? So someone joining a new project, they can choose the API when creating the database, and then they can just use it, right? So there is no learning curve on that. But what about cost? I've heard a lot of people being burned with Cosmos DB because of the cost, right? In fact, I've got a friend of mine, William, who put together a blog post about spending, tracking the spending with Cosmos DB, which is pretty good. So the way he did, he's tracking the spending on every code change that he made in the system. So if the developer makes like not that good code, the CI pipeline is going to track that, and it's going to say, hey, this is going to cost a lot, which is pretty good. So if you can learn more about the approach that he did on his blog, if you want. Or you can just go to the next talk. So he's talking right now, but that would be rude to go now. All right. You can get the video later. But most of the people that have been burned before with Cosmos DB, they would probably change the name from Cosmos DB to Cosmos DB, because a lot of people had this problem. But if you have a look at the capacity calculator in Azure, what Azure provides, you're going to see that the cost can be pretty minimum depending on your structure. So let's take an example of a simple system, not too small, where we have 10 gigabytes of data. Each document size is going to be 10 KB. I know it sounds small, but for a document, that's a fair size. And then you have 40 reads per second and 30 writes per second. So that's a decent size. If you think about it, you can have 1,000 users in your system, about 20 or 30 concurrent users, and these two are going to be fine. And what you're going to pay for that is just 25 bucks. Well, in US dollars, so it's about 30 bucks Australian dollars. So that's pretty small. If you think about a SQL database, you're going to pay way more than 25 bucks. But again, you can be burned, and if you're not smart, you can be burned. If you scale up and your document is now a megabyte per document, so if you start storing images in there, and then you have 1,000 reads and 1,000 writes, then you're going to start paying quite a lot. 45 grand is quite a lot. But it depends on your system. So if it justifies, so if you have a system big enough to use that, well, you probably have enough money to pay all that much, right? I had a good story about the cost and how I saved money moving to Cosmos DB. So the project that I was working on, we had a SQL database, an Azure SQL, and I was ingesting quite a lot of data, right? So I had it was a microservices getting data from a bunch of data providers and going to a SQL database. But eventually, the SQL database wasn't able to handle all that data coming in. And even though it wasn't a huge amount of data, the frequency was quite high. So SQL was just sitting on the ground and crying because it couldn't handle. So I had to bump up, I had to scale up several times until it was way too expensive to maintain the SQL box. So I thought, well, I'm paying that much. I can move to Cosmos DB and give it a try. Maybe it's going to be cheaper. So I did the move. After I did the move, I was able to save half of the cost. Not that, not only that, but I was able to ingest 10 times the data I was ingesting before. So if you think about it, it's not even half of the cost. It's going to be way more savings than that. So you just got to be smart. So another story about saving money on moving to Cosmos DB was when I moved from Redis cache to Cosmos DB. So I actually put a blog post about how I did it and how much I saved on that. So I had an instance of Redis in Azure, and I was paying about $150. And that was the minimum I could get on Azure. That was the smallest instance you can get with Redis. So I thought, well, I'm paying that much for caching, and I'm not even using the caching that massively, right? I'm using caching, I need the cache, but it doesn't justify paying $150 a month just for cache. So I moved to the smallest instance of Cosmos, and I could save 120 bucks just by moving. I didn't lose anything in performance, but I was able to save $120. So I started paying just 30 bucks a month with Cosmos DB instead of 150 on Redis. That's a good story about cost. So how do we get started? Getting started with Cosmos DB is super, super simple. So you can go to the portal, to the Azure portal, click on that plus button, look for Azure Cosmos DB. Then you can move ahead, click on that create button. At this point in time, you're going to choose which API you're going to use to communicate with your Cosmos DB instance. So changing the API is not easy. If you're not sure which API you're going to use, that's something that you're going to need to do some research. And that's the time you choose your API. So right now I'm going to choose the core API because I'm familiar with SQL, and I'm going to move along. I've used a bunch of Azure products in the past and a bunch of other providers' products, but so far, the Cosmos DB experience with the Quick Start was the best one of all the products that I used, and I'll show you why. So once you have your instance created, in the Quick Start, you can choose your platform. So right now, I'm using .NET Core quite a lot, and I'm sure a lot of you would be using .NET Core. And from here, what you can do is you can create this sample collection, which is the items collection. In comparison to SQL, that would be like a table in SQL. And once you create that, you can download a sample application to talk to the database. So you can find a lot of sample applications for a lot of technologies. And that's cool. So you download the sample application, you update the connection strings and stuff like that, and then you're talking to your instance, right? But not Cosmos DB. Once you download that, it's already talking to your database, which is amazing. So they put some effort to put this together, right? So when you download that, it's just a matter of opening with Visual Studio or Rider or whatever you use, and then F5, and you're talking to your database instance, which is pretty amazing. And once you have some data, you can go to the Data Explorer, which is similar to SQL Management Studio, obviously not that powerful, but you can see the data coming through. So let's have a look on how that works. So I've got my instance in Azure, and I'm going to create the items collection. So I'm going to download the .NET Core app, which is a simple MVC application. So I'm going to save that. I'm going to extract that to the same folder. So hopefully that's not going to take too long. Cool. So I'm going to open that up. I'm going to open my solution. Who here is using Rider? Wow, just a few, not even 10. It's awesome. I love it. The only problem I found with Rider right now is the Solution Explorer being the wrong side of the screen. All right, so I'm going to finish loading that. It's going to restore the package, and as soon as it finishes restoring, I'm just going to press F5, and then we're going to run the application. All right, running now. All right, so as soon as it finishes, it's going to open the browser and it's going to show the sample application. Okay, here we go. Close that. All right, so that's a simple to-do app. Okay, so I'm just going to go back to the quick start. I'm just going to open the Data Explorer so we can see the data flowing through. All right. So if you come here, I'm just going to open that in full screen, just so it's more visible. All right, so I've got the to-do list and the items collection. And in the documents, you can see that we have nothing. All right. Cool. All right, so I'm going to create a few items here just so we can see how we can query the data and how the data flows through my Cosmos DB instance. So I'm going to create here buy milk on my way home. It's going to create a couple of more. Have breakfast with my mate Jason. Create. Create another two here just so we have enough data. Bring juice. For Brandon to drink. All right, just one last one. All right, drink more water in the morning. Cool. Now I have 4 records. I'm just going to change the have breakfast with my mate Jason because I already had breakfast with him. I'm just going to complete that. Cool. All right, so now I have 4 documents in my database. Right. So I'm going to go to the Azure Data Explorer, and now you can see that we have some data coming through to the instance that I just created. Right. So this one has the flag, is complete, true, and that's it. So the data is coming through. I'm going to create a query just so you can see how similar that is with SQL. So you can see the syntax here, select star from C. So that's pretty familiar, right? So the only difference here is that query, the context of that query is not a database, is the collection. So the C is just an alias for the collection. So you can see that when I run that, I got the 4 records. Now we're going to do some filtering here. So where C dot is complete, oops, equals true. All right, so if I run that, I will get 1 record back. Cool, it's pretty familiar. But that's kind of JavaScript, so I can just remove the equals true as well, and it works. All right, so this syntax is slightly different. So I can use the not, and that still works. All right. So let's try something different. Let's try now CNAME like beer. That's a common syntax, isn't it? So does that work? We'll see. If I run that, it doesn't work. Is that because I missed beer, or I definitely had beer there? So the syntax is slightly different. So instead of doing the like, I'm going to use contains. It's more like JavaScript like. But when I run that, oh, I don't have any beer. I'm pretty sure I had beer there. Don't I have beer? No, I'm sure I had beer there. All right, let me try it out. No, I had beer there. I'm sure I had beer there. Let me see. If I don't have beer there, that's a problem. shots. I would have shots there. Oh God. All right. Yeah, I don't have beer there. I'll have to fix that later. That's a problem. All right. So let me do contain cname water. Yeah, I have water there. I still think not having beers is a problem. All right. So I've got to drink more water in the morning. Cool. So another thing that we can do, you can define which fields you want Cosmos DB to bring back to you. So I can define here the ID, name, and is complete. So if you're looking for a slimmer response, that's what you can do to get less data in the payload. All right. So a couple of more things that Cosmos DB has available is the concept of store procedure as well and triggers, right? So if I create a new store procedure, you're going to see that it's pretty familiar. So it doesn't use the whole SQL syntax. It's just a JavaScript function, which is pretty cool. But I'm going to create here now a new user-defined function to fix my problem. So I'm going to create a function called beerfi. I'm going to get that value in. And what I'm going to do here is replace whatever comes in by beer. I'm going to use regular expression. Who likes regular expression here? Oh my God, only one person. All right, I'm the second person who likes. All right, so I'm going to replace now, I think, juice. I'm going to replace water. I'm going to replace breakfast, and I'm going to replace milk. All right? Okay, so I'm going to save that. And now what I'm going to do, I'm just going to close this store procedure here. And I'm going to call that user-defined function, UDF beerfi. And now I can put an alias for the name to keep the same name. All right, and then I can run that. And there you go. Now I fixed the problem. So buy beer on my way home, have beer with my mate Jason, and bring beer for Brandon to drink, and drink more beer in the morning. I'm not sure if my liver is gonna survive after that, but well, I fixed the problem, right? Another cool thing that Cosmos DB has is the concept of triggers. So you can use Azure functions to trigger that. But before I get there, I'm just going to show you quickly how the sample code looks like. It's a really simple application with a single controller, with the items controller. And you can see here it has, I'm just going to open that up. All right. So you can see here I've got the create, which brings the data in, and then use the repository to update, to create the data in the database, in the Cosmos database. All right. And in the repository, you can see that all the configuration is in the code. Well, that's not the best way to do it, probably. It probably should be in a app settings or web config or something like that. But well, that works. We can replace that later. Okay. So once I have that, with all these details here, I'm going to create the client, the document client, which uses the document DB API behind the scenes. So if I check the CS Proj, you can see that we're using the document DB core. All right. So as soon as we move to the EF core, that's not what we're going to use, but just so you can see an alternative for what you can do with Cosmos DB. So with the client, we're going to use the client to create the document. All right, pretty straightforward. Okay. What about the tooling? About a year ago, probably this time in the year, I put together a talk about logic apps. And in this logic apps talk, I put together a simple application that would get data from Twitter and it would run a bunch of analytics, and it would save to a Cosmos DB instance. And after the talk, I didn't know exactly what to do with the database, and I left it running. So I was paying $100 a month, but because I didn't know what to do with it, I just left it running, and I was constantly paying that $100. Well, it wasn't coming out of my pocket; it was coming from the credits. But even though I was paying for that, but eventually I found out about this tool, the data migration tool, which I probably should have known that before, so I could save more money. But anyway, so that's a data migration tool used with the document DB, the old document DB. And it's pretty cool. So let's have a look on how that works. So with my collection, what I'm going to do is I'm going to export all those data from the Cosmos DB instance to a JSON file. So you can see that coming. So I'm going to choose the source here. So I'm going to choose document database. You could use that for MongoDB as well. So it doesn't necessarily need to be Cosmos DB. I'm going to get the key. Please don't take a photo. All right. So I'm going to go to the Data Explorer just to check the database name. So it's ToDo List. So I'm going to put the connection string here. I'm going to set the database. It's ToDo List. And the collection name. It's items. I'm just going to do a select stuff from. So now I'm going to export that to a single JSON file, right? So I'm going to save that to desktop, to-dos. Okay, I could prettify the JSON, but I won't bother at this point in time. I'm going to click next, next, and export. So I've got the 4 records coming through. Okay, so let's check that file. So I've got the to-dos here, and there you go. Well, the problem with the BA is still here, isn't it? Well, I'll fix that later. But there you go. That's how simple it is to export the data from Cosmos DB so you can use somewhere else if you want. One thing that you should do from day one, if you're working with Cosmos DB, is using the emulator as well. Unfortunately, the emulator is available only for Windows, not for Mac. And what it does is it emulates Cosmos DB locally. So you can use Cosmos DB the same way you would use in Azure, but running locally, which is pretty good. So let's have a look. I'm going to run the Azure Cosmos DB emulator here, which is going to run in the background. Okay. So it's going to look very, very similar to the Azure portal. So that's how it looks, all right? But it's running on localhost. So what I'm going to do, I'm going to copy this connection string. All right, so you can see that I have nothing in the data in my local instance. And I'm going to replace in that sample database, in that sample application. So I'm going to replace the connection string here. So I'm going to set the key. All right, so I'm going to remove a few things here. So I'm going to get the endpoint and put up. Okay, and I'm going to remove that. Cool, too easy. All right, so I'm going to save and run, just so you guys can see that when I add some data, it flows through to the local instance. All right, so it's running. I'm just going to create a simple one here. So you can see that the to-do list database was created and the items collection was created as well. So now I'm going to create a new item. That's a local instance. And create. Cool. All right, so now I can see that I can develop locally with Cosmos DB. All right. Awesome. All right, finally, we're going to add EF core to the mix. And with that, I've got a cool story as well. When I found out about the new Cosmos provider for EF core, I was super excited. I was super pumped. And that was over a year ago, probably close to 2 years ago. And I was super excited. So I was one of the first ones to use that provider. And I even put a blog post together, so I was really excited. And then eventually I was accepted to speak at a conference about that, about Cosmos DB with EF core. So I went back to my blog post to follow my own steps, because that's what I use my blog for, to remember what I did in the past. And I followed step by step, and it wasn't working. It wasn't finding the package, right? The EF provider. So I went there, I went step by step, like I ensured that it was right, like it is right, why it's not finding. So eventually I found a link straight to NuGet to get to this package, because even when I went to NuGet.org and looked for Cosmos DB, I couldn't find either. So I found the link and I went straight in, and I was happy, like I could breathe now. Like the package is there, I can go ahead and put together the talk. So that's what I found, and I was happy. I was good. And then I started reading a little bit more in the package, and then I found this yellow box here, and I was about to present, right? I was putting together the talk, and I found out that the package was being deprecated and shouldn't be used anymore, and I was going to present on something deprecated. So my first reaction was to freak out. Like I couldn't believe that I was going to talk about something that it was deprecated. But eventually, I found out that they just renamed the package, and then I could breathe again. They just removed the .sql at the end.
Did they make any other changes?
At the time, it was the name, and they added some features, but well, it was all good. I was happy. But I did freak out. All right, so let's see how that works. Wow, that's loud. Okay, I've got a sample app here, and it's on my GitHub if you want to check it out. I can put the link on Twitter if you guys want. I'm going to copy that connection string, that local one, because I'm going to develop with the local instance. So this is my sample app, which is a pretty simple app. It's got Angular in the front end and .NET Core in the back end, with a bunch of cool stuff to link together. So it's using the clean architecture. All right. So I've got my solution opening. So I'm going to go through on how the application works, and then I'm going to come back and show you how the EF is wired up, right? So I'm just going to replace some values in the app settings here. So I'm going to set the endpoint. I'm going to set the private key, and I'm going to set the name to blog. So I'm just going to create a whole system for my blog. Okay, so you can see that domain here is quite simple. All I have here is author, category, and post, right? Super simple. And in post, you have a reference to author and to category. All right. And the controller is quite simple as well. I only have one controller, post controller, and all it does is it fetches all the posts, and it creates a post as well. So that's all it does. Not fancy at all. If we check it out, the command, so you can see that I instantiate a new entity with the post. Okay, and then I bind some details to the post coming from the model. So it's super simple. At this point here, I'm not even checking if there is the author in the database. I'm just creating one every time, just so you can see how that plays together. Right, and once that's done, I use anti-framework just to call the add for the post and save changes. Cool, no surprises here. All right. Close that. And in the DB context, as you can see, it's really vanilla. So I only have 3 DB sets, one for posts, one for categories, and one for authors. So it's really vanilla. At this point in time, these would work with any database at all. It's just a matter of wiring up which provider you're going to use. So if you go to the web and go to the startup, that's how you link that together, which is pretty straightforward. Instead of adding SQL and using SQL, that's how it works. So you're going to add the DB context and use Cosmos instead, right? It is that simple. And then the configuration is going to come from the app settings, right? With that, you have all the default configuration and everything is just going to work. So I'm going to run that just so you can see how that plays out with the default configuration. Okay, that's finishing building. And I've got the application running here. Awesome. All right, so now that the application is running, if I refresh the Data Explorer, you're going to see that I've got a blog database, which I defined, and I have a blog DB context collection. Honestly, I don't like the name on these, so it basically said the default name was the name of the DB context. But I can live with that, right? So let's create a post just so we can see how the data comes through to the database. So I'm going to put a getting started with Cosmos DB. The category is going to be Cosmos, author is going to be Thiago Passos, and the content is awesome. So I'm going to add that and see how the data comes through to the database. All right, so if I refresh here, I'm expecting 1 document, right? No, I have 3. So why is that? So when you go and check the document, you have the post here. So you can see the content is awesome, right? And then it created this discriminator, which is post, which is actually pretty awesome because you have polymorphism out of the box with no configuration. And then it added a reference to author and category, and they are in different documents within the same collection. It's pretty interesting. But coming from a SQL background, having everything in the same collection didn't sound right to me at the time. So I wanted to change that. But before I change that, what I want to change is the name of the default collection, because I didn't like the default collection to be the name of the DB context. So let's change that. So if I go now, I'm just going to stop here, go back to my DB context, and I'm going to override the default values of Cosmos DB. So I'm going to override I'm going to go to the own model creating, and I'm going to override the default behavior of the collection name. So if I get the infrastructure here coming from Cosmos, I can override the convention and set the default container name to be default, right? So now what's going to happen is if I don't have the container name for a specific collection, everything is going to sit on the default collection instead of having a blog DB context, right? So let's run that and see how that plays out. Okay. So once this refreshes, I shouldn't see any posts because now it's coming from the default collection. And you can see I have a new collection called default here, which has no documents. Right? So if I create a new post, Okay, great. I add that. Now I should see 3 documents coming to the default collection, right? So now it's looking to me is slightly better because now I have control to the name of the collection. But I still don't like the idea of everything being in the same bucket, right? I like to have more control over that as well. So what I'm going to do now, I'm going to go back to my DB context, and I'm going to override the name of the container or the collection for one only DB set or one entity. So I'm going to use that. I'm going to get the entity post, and I'm going to override the container name to be the name of posts, which is going to be posts, right? So now because of overridden that, what's going to happen is when I create a post, the post itself is going to sit on the post collection, and all the other entities will sit on the default collection, right? So I'm going to create a new post. So you can see that I have a new post collection with no documents. So now I'm going to create a new document here just so we can have a look. So new post, category Cosmos, author Thiago, and content great. And I add that. All right. Cool. So you can see now, if I refresh here, I have 1 document in the posts, and in the default collection, I should have an extra 2 documents coming up. So I had 3 before, and now I have the extra 2 that went through, right? So that's probably the ideal scenario because all these helper data or these data that are not used very often, you can put in the same bucket because every collection is scaled separately. But if you want each DB set to have its own collection, I created a helper method here to use reflection, and it goes through all the DB sets and it creates its own container. So I'm going to set the container name for every DB set. And now if I run that, we're going to have a collection per DB set. It's probably not something that I would do in production because what I was saying, each collection can scale separately. So I would probably put all the reference data in one single collection so we don't need to scale that much. So I'm going to create a post here just so you guys can see. So the new post has no category in authors because now we're bringing from the different collections, right? So we've got authors and categories collection, which has nothing so far. All right, so I'm going to create a new one here, brand new category Azure, author Thiago. Oh my God. All right, add that. Okay. All right, so I've got a new document here, and now you're going to see that I have a new author coming up in the authors collection, and the category is going to be in the category collection, and I'll have a new post coming up in the post collection. All right. From a person who comes from the SQL world, having that in separate collection makes sense, right? But from the Cosmos DB perspective, it doesn't make quite sense. You should put the data that are not used that often in one single collection because then you're not going to pay more for that, right? All right. So after that, the Cosmos DB team that created the provider, they have a to-do list. And when I created this talk in the first place, they were still in RC, right? So they have a to-do, a task list of all the features that they're going to release. And you can check that in the GitHub issue. So a bunch of features were already released. So it's ready to be used. But now they have released. It's in RTM already, so it's ready to be used, and they actually closed the issue. So you can actually go to NuGet, and you can see that you have a version ready to go, and it's outside of preview, so you can use now if you want. So just a recap here. What is Cosmos DB and why? Well, you should use just because it's awesome. Just check it out, right? The getting started experience with Cosmos DB is amazing. It's probably the best F5 experience I've had in a long time. And wiring up AEF Core, it's so easy, and the implementation is really clever, especially with the polymorphism. And then I shared as well some of the tooling, especially the tooling that you're gonna be able to use locally. So you can develop your application, and then you're gonna start paying for the Cosmos instance. And what's next? Well, you should watch the test list, but in fact, you can start using the NuGet package right now to wire up your EF Core to Cosmos DB. And that's it. Thank you very much. I think we have time for questions if you guys want. Up to you. Nope. Good. Yep.
Have you looked into like any containers can run Cosmos? You mentioned that there's Cosmos Emulator. Can you run it in a container? Because, for example, in scenarios when you want to run some integration tests.
If I know if you can run the Cosmos DB emulator in a container. Yeah. I haven't used that in a container. No, I haven't used that. Yep.
So you touched briefly on the fact that you can set it up with different APIs to query it.
Yep.
Does that affect how the data is stored, or only?
All right. So all the different APIs, if they store differently, they are actually. So the MongoDB and the core API, which use SQL, they use the document DB under the hood. But if you choose Gremlin, that's going to use Graph. So they have yeah. So for MongoDB and SQL, the SQL API, they use the document DB under the covers. But all the other APIs, they have different database structures under the covers. Yeah. Yeah. So the Cosmos DB is all about all those features around the database itself. Yes, the EF Core implementation is just for SQL, yes. Say it again, sorry? All right. If you can migrate data coming from SQL to Cosmos DB, yeah, you can migrate that. So you can, if you export the data from SQL as a JSON, you can import that into the database, into the Cosmos database, and you can start using it. And I think, if I'm not mistaken, the whole SQL has the ability to do that as well, not only with the data migrator. Yeah. Yeah. If Cosmos DB has logging. Locking. That's a good question. I haven't come across to that, unfortunately. If it locks the document, not sure. I can have a look if you want. Yeah. Yes. Sorry, say it again.
Looks like the backup only gets stored for 30 days.
The backup stored for 30 days. If you can set the expiry for the backup more than 30 days, I think you can move that backup to a storage account instead of the backup itself. But but I haven't used the backup extensively, unfortunately. Yeah.
With regards to the different APIs,
Yes.
is there any one that's like that are recommended in terms of performance or features?
Regarding API, if any API is more performant than others. When you're asking the API, you're asking about the difference between SQL API and the Mongo API, if they are more performant. If you talk about between Mongo and DB, I wouldn't say so, because they are talking to the same document database under the line. But
More along the lines as if the API had more overhead. So, for example, SQL had to, had some extra overhead versus MongoDB. So that's just kind of
yeah, no, I understand that. I wouldn't say for between Mongo and SQL. I wouldn't say that because it's the same underlining engine. But maybe if you're trying to do something like graph, and the structure you want to use is more like a graph sort of a structure, then you would have overheads. Yeah. Any more?
Question about your example with the light, when you were doing the search for the word beer.
Yeah.
If there were like 1 million documents, how would that perform?
If you have a million documents and you search for a beer, the way Cosmos DB works, if you have a million documents, it's gonna add paging to the query, and that happens automatically. When you query, it's never gonna return a million records at once. So the way it works, if you're working with Cosmos DB, it creates the first page and it returns to you like a token to get the next page. So you have to loop through to get all the documents at once if you want. But when you want to return documents, you're probably going to return page by page if you have a million records. But it does. If you have the concept of index, yeah, definitely. You can definitely add indexes. Yeah.
Yeah, I was just wondering why it's classed as no SQL database, because we were writing SQL.
Why it's classed as no SQL database? Well, because underlining is no SQL. So it's a document database.
SQL's about it being like storing JSON documents.
Yes.
It's querying with SQL.
Yeah, but it's not a relational database, and that's what the point is. Yeah.
Just added with that, it's actually not only SQL, and that's why supports all the different models. Not just SQL, you've got Mongo, Cassandra, Table, what's the other one? Prism.
Different query languages you can use.
Mm-hmm.
That's right. Just SQL
Do you have a question?
when you were talking about paging, and obviously paging the API, obviously with any sort of API, there's limitations. What limitations are in place with, for example, a page like API limits, as we say?
The API limits in which regard?
So, for example, let's say you're querying. Okay, let's just use another example. So, if you're querying a REST service, let's say Graph, MS Graph, for example, you would have a specific set of API limits that you can only make a certain amount of calls per hour before you actually Microsoft interface. Is there any sort of limitations like that within Mongo?
If there are any limitations with that, when you're using the Mongo API, well, at the end of the day, if you make one call, that's what you're gonna pay for, right? So if you make 1,000 calls per second, that's what you're gonna pay, right? So it scales on demand. So if you make more calls, there is virtually no limitation about how many calls you can make a second.
Okay, so it's not based on a time frame, it's based on cost. So
Yeah, but when you create your instance, you can define the limits of how much you're going to use, and after that, it's going to start throttling the calls. But then you can scale as much as you want, and then it's not going to throttle anymore. Yeah. But then it's going to it gets expensive, as I showed you. Yeah.
Select star.
Yeah. Yeah. No worries. Thank you.
So assuming you can mix with the NoSQL and the SQL together, combining the different provider of Cosmos DB and SQL Server DB?
If you can use the different APIs, is that the question?
No, I mean if in the same project, can you use both Cosmos DB and the SQL Server DB as a different administration?
If you can use Cosmos DB and SQL, the SQL provider,
Yes.
in the same project,
Yes.
when you're talking about that, you're talking about different DB contexts, or you're talking about different environments? Because if you're talking about different environments, it's all about how you configure the startup. So if you go locally, you want to use SQL. If you go production, you're going to use Cosmos DB. You can set up that in the startup, right? And then everything's going to go through. But if you're talking about different document DB contexts using different database types, it doesn't really matter. So it's just about how you configure. So you one DB context can use Postgres or SQL or whatever you want. The other one can use Cosmos DB or whatever you want. Doesn't matter. Cool. Thank you. Thank you for coming.